Yeah, so can you see the slide as well? Okay, good, 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 good. And so that, yeah, we should start it now, since we have a couple of things need to do for today. Yeah, and first of all, we know that we had the midterm test last week. So for the tutorial session, or I say that after the lecture, I have asked Vahi, our teaching assistant, that he will gonna also explain it and discusses about a solution with you guys. And but however, we haven't really had the time to grade it all of the to market all the midterm test. So I hope that the result can be available probably next week or the week after next week. Yeah, we will try our best, and I also hope that everyone really did well. And so yeah, this is the first one that we will explain it about the solution. Yeah, and I think after that we also uploaded the solution to you guys for references. And yeah, but we also have the tutorial today. And I think the question, yeah, it's not that long. You may, and if you need more time, you just let us know. We can extend the deadline things that I don't know how long that you need it for, like to check it about the solution of the midterm. And you probably also have some questions to Bahi. And other than that, you also, I think most of the group, also that I say it's optional, but most of the group have submitted and sent their interim report about your final project, the group project to me last week as well. And I think I replied it most of the groups, and I also had some discussion. And so overall, I think most of the all the groups, the interim report are quite good. I'm just a bit a bit worried about is that like too many groups selected the third runway as your project. All right, so that please make sure that if you select the third runway as your group project, you probably need to really think about that, how to really narrow down the scope of your project and to go to more specific topics so that you can really work on that and differentiate it with the others. All right, so that yeah, this is just only one of my concerns. But the other things, I think the contents about the references, the information that you collected, and also the format of the report, I think most of the group did quite well. Okay, quite well. And then yeah, not only about these comments. If you have any further questions, just email me. You can make another appointment with me. Yeah, you can discuss further about any details about your group report. All right. So and actually, I think I will also gonna demonstrate one of the example that about the group report, like which group like did in the past years, so that you can have a more idea that okay, then what is the final report should looks like. But I don't want to really show you too much because you will gonna limited it about your creativity. Like why I say creativity is that also that I mentioned some content that you at least you need to include it, but not limited to, right? So that you can really do whatever you want, especially to keep improve it about the big model that you're gonna develop it. Yeah, since you still have time to really work on that. Yeah, but then I what I was gonna show you will be kind of like I would say the basic requirement that I hope that at least that all the group report can achieve. All right. So then, yeah, that will be what we will have for today. So that we're gonna start it with our lecture today. All right, and then we will discuss those things in later. So then we started with the lecture part, and then today we're gonna talk about the project control. All right, and especially focus on the two techniques. I don't know whether we have sufficient time to do the unscheduled. Yeah, but at least we will talk about the value management today. Oh, sorry, I think there is a typo. I must correct it here. All right. So that yeah. So when we start, I actually also want to raise some of the concerns, or I would say some news that we can really look at about. All right. And let me see if we can. Okay, let me actually share the whole screen with you. All right. Let me see. So you see that why I use this case is because remember that what we did from the previous weeks before the midterm test, we all talk about those kind of planning things. We care about the money, we care about the schedule, and also talk about how we can assign the resources and even like do a trade off between the time and the resources, right? The time and the money, right? So that we discuss all this kind of thing. But for those kind of thing we talk, it's more like we're in the very beginning stage, we so-called the planning stage of the project of the infrastructure, right? So that we did most of the things that before it really be constructed. So but however, there are lots of the problem when you look at about the news. I think there is some this kind of infrastructure like bad news every day, not every day, but it's always have that kind of things that, for example, like this. What now for the Hong Kong's over budget Shatian Central Link? All right, because this one hasn't been finished. And then I think a few years ago, and you may see lots of the new also news about the high speed rail because it is also kind of like this. It's over time. It's just like over budget, and why those kind of things always happen. And then this is also the things that the MTR numbers did not also tell the full story. So that I would like to also share some news from South China Morning Post to you guys. And then I think this is a few years ago, but then this is kind of like they keep updating it, but this kind of problem already happened. And then they already see that these kind of things that a few years ago. So you can check it here that much delayed the 70 kilo lines for 70-kilometer line from the new territory to NMRT is nearly completion. Not actually, you see that it's 4 years ago and saying being mid completion, but did it really complete it yet? No. So, but then still, they needed more and even more public money from LECO. Yeah, so you can see that like after decade of planning, this is also what would like what we learned from the subjects and consultation, revision, and construction delay, and some buildings there is finally light at the end of the expensive duct tunnels for Hong Kong Shatian Central Link as the building work comes to completion. And then you can see like a lot of the other major infrastructure development in Hong Kong. Yeah, I see all these kind of infrastructure development just meet this kind of problem. And then they did not really hit this projected completion day or hit its budget. In fact, it's now the most expensive rail project in the city's history, and also probably the most expensive one in the world. I mean, in the world, real. It's like 10 times than those MTR, the railway that did in China. And so we can see the MTR Corporation, like which building the line paid for by the government, like announced on the Tuesday, at budget overrun like 16.5 billion and bringing the total bill to almost 100 billion, and that made it even more expensive than the Hong Kong section of the controversial high-speed rail project. Okay, so this one is even more expensive. All right. So then you may now curious that okay, then why this cause these kind of things happen? Okay. And then so how can we really do and what happens now? You can see here is like they just never confirmed until a Tuesday. how much costs that deviated from the original estimate but delay and design reconfiguration like its clocked construction since work began in 2012. All right. So what is difference? Now it's 2022, and then for the planning, the cost they did estimated is in the 10 years ago. And if we consider this kind of inflation, like I said, that in the public, in inflation, in that kind of economy development, for the 10 years, of course, those kind of planning for the money things won't be as close as like 10 years after. So this is also the problem, right? Because it's already what last too long. And then so the you can see also the Transport and Housing Bureau say this reserved comments like on the revised cost estimate, adding would extend the corporation's justification before deciding whether to foot the bill. But when these kind of things happen, do you think that the government can say no, I won't give you the money? If this happens, then how this project can be complete, right? So then you can also see, okay, this is just the give you more background. If you are from overseas, you didn't know this slide, and you can also check it. And the construction site actually just outside of our university, that the Cross Harbor Tunnel. Now the construction site is still there because they haven't finished it. So now they would like to finish this part, like from Hong Kong to the exhibition century and linked it to the Admiralty. All right, so this is still under construction. So why the different figure be given for the total cost of the project? So when revealing cost overrun on Tuesday, that the Antia Corporation gave the new total of the cost. Okay, because the main construction works of the project, which was the 87.3 billions. But when everything taken into account, the final price tag is like 97.1 billion, and including the original approved total funding is like 79.8 billion. So it's just like have a many like this kind of 16.5 billions overrun, right? And then of course they say that there's some external factor is always happen, like for infrastructure project. So including like archaeological finds at the site of the new Song Wong Toi station, like which cost an additional cost of 4.1 billion. Okay, so this actually is also kind of controversial. Do we really want to, I would say that pay this kind of additional cost to conserve, to have the conservation of those archaeological finds? Okay, yeah, but obviously, if you have money, of course, this should be reserved. This should be preserved. And so the late of the or the incomplete the handover from the government of the construction site in the one time, and government official asking for additional work such as budget foundation works at the exhibition century station. So cause this kind of delay and extra cost, and the company say, okay, so this they have those kind of justification. And what about the other 30%? Okay, so then this is including the level shortage. This is also a very major problems in Hong Kong's the past few years. Yeah, we really lack this kind of labor because Hong Kong, we didn't really hire those foreign laborers like from Philippines or Thailand or other kind of country. We didn't do that like Singapore did, so that we only hire the local worker. So this is also another issue. And then you can see that we have 10% to 20% in the construction sector because this is kind of the unfavorable ground and also the unfavorable ground condition and changing design work according to the corporation. All right, so that all this kind of thing happens, and which is not really included or considering in the planning stage. And another also news is here like partial opening of the scandal hit the Shatin Central Link set for the Valentine's Day. Really, it's like 2 years ago, and then yeah, obviously it haven't really did that now. So move will also push up the total cost to record it like 99.1 billion. You can see that, yeah, it's after 2 years. I don't know what happened now, but of course, I believe it should be already surpassed 100 billion. So that you can also check it. There's still the problem that's still there, right? so that it's just like we cannot really be finished. This project cannot really be finished. So this why I use these two uh, uh, news it to explain it before the lecture really started. It's because I would like to let you know that okay, planning is not enough. Planning is not enough. Since that when we started to work on those infrastructure projects, there are too many uncertainty. So we must to really understand it. Okay, when the project started, how can we really control our project? Means that for those cost estimation, for those scheduling things that you did, is not directly linked to the real situation of the construction. All right. So even that you did the perfect planning, but it won't always goes as that what you plan. Ideally, of course, it's not like that. Ideally, of course, that we hope that those kind of construction can do as close as the plan, but it never happened, right? So what we can do is actually to really check if we can really make it happen. Okay, so then for today's class, we will gonna talk that after the planning, how can we do when the infrastructure, those construction really started, when the project started, how can we really control those projects? All right, so then as what we had in the previous week, also that we talked about those kind of problems. I would like to let you know that how importance of these kind of things, but we will start it with a very basic idea and then to let you know that how can we do. All right. So for today's class, you can see that I summarized what you learned from previous week. That now you know how to use the work with the structure, right? Define the work, and then so once those the infrastructure, those projects divide can be divided into those or small tasks like different level, right? So then you can also even link it with those the relationship between those tasks. So you can schedule the work that using the network and then allocated those budget, those resources into the project. So this is generally like what you can do in the Microsoft project, right? So that I also found that some of the group already try to use it Microsoft project for their interim report, which is good. But I will also look at about that in final report if you can have a more detailed, I would say, and more professional report based on the Microsoft project. So that once you make these kind of all the plan and assign those and allocated the budget and resources, you can see that it will result it in a very I would say this kind of contract budget base means that uh, for the time being from the beginning of the project to the end of the project, right? So that it will accumulate it the cost that from the beginning to the end, right? And then the y-axis will be the money. So it means that this kind of S curve can really show that the progress of a project, like for example, in the very beginning, in the design stage, you probably only need the manpower to do those kind of design work, right? So that the line will start to increase, but not dramatically. But then after that, in the middle of the project, since that all the material, all the manpower need to put it in the construction side, all the equipment also, right? So that it will be increasing dramatically that in the middle and then become smoothly again, the slope becomes smoothly again that to the end of the project, right? So this is kind of like you can imagine that for those accumulated costs, if we also through the whole the time frame, it will result this kind of so-called the project management baseline. Okay, this is a project management baseline. So simply say that then we will again have an idea that okay, after 1 month, 2 months, 3 months, and then what will be the expected cost that you're gonna spend. Okay, so this is how we do for the budgeting, that also for the space and scheduling And then we also have this management reserve. Usually it's like a 10% for the infrastructure project. And the management reserve is used to really to cover those uncertainty and the risks. So that, but however, I just show you about the starting scheduling. Of course, it's not only 10%, it's 30% or even more. Okay, then request more and surpass this management reserve. Okay, so that then this is just for the base that now you know. After we have all the planning, then we can get this S curve, right? But how can we do the control? Is that we were gonna versus the real, the real money that you spend it, the real, um, I would say the progress that the project be conduct. Okay, and also that also take into account about the time frame being that based on schedule, right? So then for this one, how can we do that is that we're gonna understand the basic of project control. We're using the technique we call the earn schedule. Sorry, the earn value. Also that we will learn schedule later. So we will start to talk about earn value, and then using this earn value for the cost and the schedule control, and we are gonna also use the earn value for forecasting. All right. So then we were gonna talk about today that how can we use the earn value management to for the project control and how we can measure the progress like planning versus the actual progress. I think this is especially important because this is the idea behind that. After the planning thing, we have a planned progress already, right? And how can we compare with the actual progress so that we can really track and understand that what is the current situation of the projects in the different kinds, in the different stage of the project. That will be the key that for today's class. And so we will talk about embedded management and how we can forecast the cost and completion. And finally, we can do the monitoring, the performance. Okay, so that's good. So we will gonna study with some problems like during the project execution that this is the kind of thing that cost is kind of delayed and the cost overrun. So many project activity that consume more than their estimated time and cost, like the case I just shown you, right? And the productivity among the project team varies and affected the overall coordination in the project. So simply say that the same project conducted by the different contractor may well have a different result. Okay, so that is also why that how to select it, like the bidding process, the tendering process, how we can select the appropriated contractor and designer are very important in construction. All right. So then the change also introduced to the scope of work that causes disruptions and cause overruns. And dealing with supplier and subcontractors may not be easy. All right, because the even that the main contractor they also need to deal with these kind of things that material supplier, equipment supplier, and other subcontractor. Yeah, that will be also cause another level of the problems. And the tracking technical progress may also be hidden from the controls. So this, to execute the project as close to as planned as possible, we need to, okay, then this is also based on a very important, I would say, assumption is that we were gonna assume that those kind of project planning is already perfect. So that all this kind of process, we were gonna track it as closer to as planned as possible. Okay, it doesn't really mean that okay you can really finish the project earlier or save a lot of money means it's better. No, it's not like that. It will cause another kind of issue. For example, too fast, uh, the save a lot of costs. Usually, it will means about a very low quality. Okay, usually it means about very low quality. So that this is just a assumption that we were gonna track the project like this, and so that we need to accurately follow the project plan and update the project plan based on the new circumstances. So this is also important that use when we using the value management and also the unscheduled, we will also gonna update this. Why we say update this is because that when we track some points of the project, then we can understand it that okay, whether we spend too much money or whether this project is like far behind the schedule or something like that, we can really understand it what is the current status of the project. And we can also monitor the execution and keep the track of the resources and provide a progress report comparing the actual versus plan. Okay, so that this is the how what the value can really do is that we will kind of show this kind of comparison, and then we based on the current the status that we get, we can also forecast the cost at completion at any project stage and take a corrective action at any stage to bring the time and cost closer to plan. So project control, we're gonna cover uh, measuring work progress, cost and schedule control, forecasting and completion, and also the schedule updating. Okay, so that we will really talk about these four different kind of the categories that in the project control. And so then we can start to talk about what is the value management. So then this is a systematic approach to the integration and measurement of the cost, schedule, and technical accomplishments on the project, right? So then the EVM is a project management tool that integrated the schedule and cost parameters of the contract. So the all the work is planned, schedule, and budget in time phase. Then this will be the plan value, okay, increment. So when we started to talk about a value management, so like what we I mentioned in the very beginning of this course, all this kind of calculation will be not that difficult, but you really need to understand. For example, what is a term like the plan value? What is term about value? Okay, or even like actual cost. So as a work is performed, it is controlled against the baseline and provide the ability to examine the detailed schedule information like critical program, a technical milestone, and also the cost data. So here is some historical backgrounds about the EVM, and you can see also like the PRT, the critical path method. This method is actually also developed based on the Department of Defense. Okay, yeah, you know that those military thing. You also saw the news that about the Russia and Ukraine war. This is the kind of like a very have a very huge impact of the economy. So that for those kind of things, those kind of track or that for the track for the cost control for those kind of things, actually they have the measure need for from the military industry, so that they have those they adapted the cost schedule control system criteria and as a kind of objective measures of progress. And like in the 1970s, and continue using the Department of Defense as a mean to offset the cost schedule risk in cost plus contracts. So now, because they are high tech, newly developed weaponry, armed race induce a critical schedule needs. And however, recently, like to the 1990s, the policy moved the value into all the federal agencies, like NASA, like Department of Energy, and and the Office of Management and Budget in the United States, they just say that to begin the enforcement in all the civilian agencies to use this. Okay, but when based on my observation, the Hong Kong Hong Kong government didn't really use this kind of thing to track. Yeah, I think the major reason is because probably in the previous year, they are too rich, so that they don't really use this kind of thing to save the money and to control the expenses, right? But probably in the future, they were gonna use it. So why I want to give you the idea to understand this is because that from the all these infrastructure and construction projects, they also that we must really understand this part. How can we really control our project? And otherwise, you would just like always to overrun the cost overrun and always delay. All right. And then why do we care? Is that the project over budget and always behind the schedule is like that. Not only about the construction, even like in the information technology, the IT projects, you can see that over half of them is just like finish over the budget and behind the schedule. But the construction is even higher. The situation is more severe. And also like the overhaul half of them as is like double of their initial budgets, and some of them 80%, not only some, is quite a few, like 80% are simply never completed. Some construction project, infrastructure project are also like that. Yeah, for example, like California high-speed rail. Okay, in Los Angeles, the high-speed rail station is just all idle there for I think it's almost 20 years. All right, just never finished. Also, that in California, the government say that okay, now they have money, they want to reactivate it, that project, but the progress actually is still very slow. Okay, it's very slow. And we also have another high-speed rail project in UK, right? Like to connect it from London through the Cambridge to Manchester. Yeah, that project I think is also kind of like has planning for over 10 years, but did not really finish yet. So then the consistent performance measures allow the comparison across portfolio is very important. So we also would like to understand those statistical performance for the projections. All right. So now this is also the key concept. We would like to have the fundamental differences, like we to let you know that like with the traditional measurement is the data used for analysis. Okay, they probably just use the budget versus the actual. What does that mean? What does that mean? Okay, remember that the S curve that I just mentioned, okay, in the beginning of the lecture, that we have base plan, we have the project management base plan. So I think most of the, I would say, traditional track progress is only used in this. Okay, if the project is 1 million, and when we spend it 500,000, we will say that okay, this project has complete 50%. Do you think this is reasonable? Is it reasonable? Or the project is for 1 year, and after 6 months, you will say that okay, this project should complete 50%. Sounds make sense, but there is also something missing, right? This is probably this in your mind, but I can tell you that for most of the government budgets, okay, or even that like our university, when we track it, how we really spend our money, how we really, if we achieved it, the goal of the budget, this is the way how we did. This is the way we did, which is I don't think is reasonable. Okay, but this is the way we did. Okay, they just say that okay, if I give you 1 million research budget, and when you spend it half of them, then I will treat it that your project have 50% finish. Okay, so sometimes I trace it by the university, say why, Mark, you didn't really spend your money. Is it progress behind? No, I say nah. It's because that I already have some arrangement later, not here, not now. Okay, so I would just like to let you know that for this kind of budget versus schedule, there are too many different too many problems with it. Okay, it cannot really track it the real progress of a project. Okay, so then that is why we're gonna talk about the unvalued management. How can we really compare with the things that we really has been conducted versus the traditional versus our plan? All right. So then for the EVN, it is performance measurements. Like we ask this kind of question is that how am I doing against my baseline plan? Okay. And the performance measurement is like what do I need to do to bring the project in on cost and schedule? Okay. So that simply I give you continue with the example I just mentioned. Okay, if I have a research project, I have 4 objectives or 4 deliverables that I need to finish. Okay, can I say that after I finish 2 of them, then I completed half of my project? This makes more sense, right? This makes more sense because I have 4 deliverables, I complete 2 of them, then I see that I can say, okay, I complete half of them. It's not like I spend half of my money, and then I claim that I have finished half of my project, right? So then, so does for these kind of things, if we applied it for infrastructure, for infrastructure. So how can we track it if a infrastructure, the completion, the percentage of completion of the infrastructure project? Okay, for example, we have 10-kilometer long road we'd like to pave. Okay, we're gonna do pavement for the road for 10 kilometer long. And then now I would say that, can we say that, okay, if I pave 5 kilometer long, then we finish 50%. Yes, right? This makes sense. This makes sense. However, for most of the government project, they will say, have you spent the half of the money of the project? Yeah, so this is a problem. So we would like to give you this kind of idea. How can we move from the traditional uh, control to the unvalue control, to the unvalue management, that we were gonna have the performance-based measurement rather than saying that we compare the actual expenses versus the original plan. All right, so what's good? Can you get an idea now? So then the EVM suitable for the project that have the clear definition of the work scope, and the project schedule range from a few months and many years, that is fine. Small to very large posts, yeah, this is also fine. But the EVM is not suitable for the project without a clear work definition or deliverable products. Okay, it is not like that. All right. So the rudiments of the EVM is based on something called earn value, that there's a concept that the test the earn value as a work progress. Like I said, we can use some deliverable, milestone, or some others. Like I just say that, can we say that, okay, the project we finished 2 deliverables and 2 of 4, and then we finished 50%. So this is the kind of idea like behind the EVM. And also that the data point that express the value of the work accomplished, this is also works. So the earn value is equal to the quantity down times the unit cost. Okay, times the unit cost. So then absolutely depending on the work breakdown structure. So this will also integrate it and link it with the WBS. So that, because WBS deliverable oriented organization responsibility identified in the WBS, and also those kind of work not in the WBS. It's just like it can be treated out of the scope, and all the lower level elements just draw up to the WBS total. Okay, so that the full definition is a key. We need to define all the develop deliverables and understand time frames and total costs to deliver a product and assign organizational responsibility. All right, so that this is, we also need the WBS here. So then what do we measure the progress against? Like the performance measurement baseline. So the budget cannot be split over the time to accomplish the scope of the work, or against with the progress can be measured. So the N value is like how much progress did we make against the original plan? And then it can express it in money or sometimes hours. But we will start with the money that we so-called N value. So we will all link about the money first. Okay, so this is what we're gonna do now. And then here we also would like to introduce the some how we can really measure those progress. Okay, there are different types of method, but this of course is not the measure the money that you spend. It's measure the work progress that you complete. Okay, you accomplish. So then you can calculate the activity percentage complete, like the unit complete is repeat the production of the easily measured units of the work. For example, like pile driving, road paving, like I just mentioned, like percentage complete is like unit complete and compare with the total units, or like incremental milestone, like applied it to the activity that include the sequences subtask. For example, installation of the major equipments, receive and expect, then we treat it, okay, 50% finish. Setting complete, and then 35% finish. Alignment complete, then we treat it 50% finish. But I think all these kind of things are still more make sense than we just say that okay, we compare with the actual cost and the budget, right? And then finally, and we have the testing complete and also accepted by owner, then it will be treated as a 100% complete. And then we can also use a start finish for activity that lack of the intermediate milestones. And supervisor opinion is more like qualitative one, but it's still doable that because some very experienced manager, they can really know that okay, when this project conducted, then they can view and overview and review those construction progress. Then the supervisor can probably give you, oh, probably then this is 30% finish, 40% finish based on their opinion. All right. So then you can also do like cost ratio for activity that are budgeted based on the work allocation of the money and involve the long time and continuity that, for example, project management QC and QA and presenting complete is equal to the actual cost of the work today and divide by the forecast and completion. And another one is called the weight or equivalent units applied to activity that are composite of the two or more overlapping subtasks, and each with a different units work unit work of measurements. For example, structural steel with a total weight of the 520 tons. Like all the subtasks are converted into equivalent steel tons as a unifying measurement units. I think this is also work because that we know that when we use it all these steels, then this project should finish. Okay, so the example is like this. So that we have different kind of weight for the subtask. For example, 2% for the round fund and balls, 2% for sheen, and 5% for shakeout, point like 6% for colors, 11% for beam, 10% for cross bases, braces, 20% for girts and the rods, and also the connections, punch leads. So you can see that different units have also associated with their total quantity. Means that those if those quantity be finished, then this part has been finished. All right. So that for this one, you can see then we do, then we can now based on this table, we know the current situation is like that. We have this because we want to calculate how can we know that this, for example, the columns is like 27.5 times is like this. We can calculate that quantitated to day 3 and divide by total quantity in the column 2. So 3 divided by 2, and then we times the weight. Weight is like in first column and also times the total steel tons. And then so for this one, for the column, we use the 74 divided by 84. Okay, because the 84 is the expected quantity that we need to finish. And then this is the current stage that we have installed using this 74. So we use this 74 divided by 84 and times this weight is 6% and also times the 520, which is the total tons of steel. So we can know that for this one, we have earned this 27.5 tons because this is the weighting for this part. And then so there's also we can trick it for the previous few subtasks. For example, for this one is 200 divided by 200 is already finished, so it's 100%, and times the weight is 2%, and also the times the 520, so we get the 10.4 for round fun and bolts, and also the sheen for 10.4 times. Okay, so that we can see if we want to know the percentage complete like this, we were gonna do is that we have sigma of the earn time. Sigma of earn time is that we because this is how we calculate. We get the 10.4, 10.4, and 25, 26, and 27.5, and we also added up the plumb and line and connection. which is 24.3 and 3.9 respectively. And then so we have the total earned towns is like 83.5. So that for the percentage complete, and we can know that, okay, we use this 83.5 divided by the 520, so that would get the 16.1% finish, okay, for this project. So this is a kind of like we show the current status. We can say that, okay, based on the earned count, that, or this also can say it's kind of like earned value, right? You just like transferred it to the earned count. And if we also treated the steel as a money thing, we can also see this is kind of the earned value, right? So then for the earned count, and also divided by the total steel tons, we now know that for this project in the current status is like 60.1% finish. Okay, 16%, 1.1% finish. All right. So that we do this like to calculate the project percentage complete, that the calculation based on the end of the period report, and the total at the end of the periods can be obtained by accumulating the total percent complete in each activity for all the work performed within the periods. So then based on those activities percentage completes, and we can calculate the overall project percent complete, that what we just shown in the previous example, like the budget value of the work done and the information related to the progress payment. Okay, so that this is the how we can do. And then for this one, you can see we can also do, and this is even go further, is that we were gonna also do this actual versus plan, and using a budget that we really spent it, right? So the first one is like to calculate the plan and versus the actual percent complete at the end of each week, and draw the S curve of the plan and versus the actual progress, and we can also compare the actual versus the plan by the end of the week 4. All right. So how about we have the 10 minutes break, then we'll come back with at 3:30. Okay, and then I will continue with this example. Okay, so yeah, let's continue. I just clarify with the questions from students. All right, so this is just like we have we treated this total tons of the steel and as 100%, and then so each has been distributed to all the subtasks. Means that the columns will be 6% of the total out of 100% towns. So it would be like if we, for example, if 6% for columns, then we can times the 520 means that the columns is 31.2 towns in this example. Okay, however, we only earn and finish this 27.5 in the current status. All right, I hope this is clear enough. So now we continue with this one that we want to compare with the planet and compare between the planet and the actual. So that you can see the different colors means the different things. All right. So the upper bar is about the planet, and the lower bar is the actual. And we would like to know that what will be current status by the end of the week 4. So then we can do some calculation that to calculate percentage conflict, that the percentage conflict at the end of each week is prorated with the actual the activity duration. And the percentage value in the chart must add it to the 100%, and calculate the weight of each activity as the activity's total budget in the proportion to the total project's cost. So the project percentage conflict at any day would be the sigma of the I equal to 1 and to the n, and the cumulative percentage conflict today and times the weight. All right, so we transform the figure to this kind of table. We can see that for the budgets, you like the task is for the task A is a 30,000, B is for 20,000, C is 10,000, D is for 40,000, and so that we can also convert it to the weighting because the total budget for this example will be 100,000. So we'll see that the 30% for task A. And then when we go for the plan versus the actual, you know that the first it will be equally distributed to the first 3 months as 3 weeks for the test A. So we have 30.333, 0.666, and 1 from week 1, week 2, and to week 3. All right. However, for the actual one, we only completed 0.1 in the week 1, 0.5 to in the week 2, and 0.9 in week 3. We finished that text A in week 4 instead of week 3. All right. So then for the text B, we have we planning to finish 1/4, like 0.25 in the week 1, and also the 0.75 in the week 2, and also the 1 in the week 3. However, the actual progress, we did nothing for the week 1, but we have the 0.7 for the week 2, and we also completed on time in week 3. And also for the text C, we plan to have the 0.25 in the week 3 and 0.75 in week 4 and 1 point in 5 and week 5. However, we completed ahead of the schedule that in the text C, we have the actual progress in the week 3 for 0.4, and we finish it in the week 4. All right. And then for the week D, we have 0.5 in the week 4, and also the 0.4 for the actual one for the week 4. So if we do that, we have the project percent complete at the end of the week number. We just do like this. We have we can do is that the plan we use this 0.333, okay, times the 30%, okay, times the 30% plus this 0.25 times 20%. So we get the week 1 plan is that for the 0.15. However, we only earn this, the 0.1 times 30% and 0, so we only get the 0.03 for the week 1 for the actual. All right, so that we continue with this one, this kind of the calculation. So we got the 0.35 for plan in week 2, 0.525 in plan for week 3, 0.775 in week 4. And for the actual one, we get a 0.29 for week 2, and 0.51 for week 3, and 0.76 for week 4. And then you can see that from the week 1 to week 4, the actual progress is actually slightly behind of the plan. However, it covered the schedule, okay, by the end of the week 5. So we still finish it in week 5. All right. So that if we draw another figure, you can compare the actual versus the plan. By the end of the week 4, it's just like this. Okay, it's just like this. Just a slightly behind of the plan of the schedule that compared with 0.76, but with the 0.775. All right. So that for the plan and versus the actual progress, you can see initially we can have the plan, we have the early started line and also the late started line. So we can have also the actual, we have the base or average line. We can draw different kind of the S curve and then versus with the actual. So if the actual can fall into, we see this kind of range from the early start to late started and very close to the base of the line, then this will be the ideal situation. The drawback is that we do not know if the extra expenses are caused by the fast execution of the more work item than planned, or simply because of the higher rates paid to execute the less work than planned. So the no indication on the amount of work for which these expenses will incur. All right. So that this is the just if we can only consider about the money that we spend, it will be like this. The time-based S-curve method that we have the planned cost, we have the actual cost compared with the actual hour, and it's also the planned work. You can see that we can just only compare. We can do it's like the actual cost minus planned cost. We use the actual hour minus the planned work. Then we can roughly understand it what will be the current progress, right? However, that is the like I said, this is just like some if we just use these kind of traditional method, they just like something missing, right? We cannot really just claim that okay, this is under budget or behind schedule. It's just like the actual cost is less than planned cost, or that the actual work is just ahead of the or the behind schedule. Just based on that, all right, we cannot really treat like this. Okay, we cannot really treat like this. This is the I want to give you an idea that for the life without the EVM, okay, life without the EVM is like this. So that the total budget of the 100,000 as an example for this one, like and also know the 12 months effort, and we want to produce the 20 units, okay. So that in the current status, we know that we spent today is the 64,000, and time elapses is like 6 months, and unit produced is a complete and two partial. Okay, you can now see that a major differences with the compared with the previous method that we just introduced. Okay, also it still shows some tracking ability. However, they actually didn't have this kind of information about the unit produce, right? So that how are you doing and how do you know how you are doing and how far along are you is like this. We can know that we have spent it 64% about the money that we spent it here, right? However, then we have the 50% spent about the time because it's 6 months. Okay, so then if we just based on the previous like traditional measures, like the money we spent it and not consider about deliverables, not consider about the actual progress, then what will be? What will be? Actually, it may show a good progress because it's spending more already. Okay, more than half. However, the thing is that the unit produced is not in the half. If it in the half, it should be we produce it 10 units, not only like 8 complete and 2 partial, right? So then the real status is that if we use the EVM, you should have complete the 50% of the work, but only compare 42 because 8 complete and 4 partial. And also that a major vendor was late in delivering certain parts, and you have spent 64% of your budget, you should isolate the main cost variance to the aluminum prices. Okay, since that this is the worst situation that you spend more but produce less. So we should do some action to take some action, things like that. So now you are forecasting the additional cost overrun for the remaining work. And now you now know that what the drivers are, and you can now take the appropriate action. Okay, so this is the real status. So this is what
we want to continue today that how we can do and track those kind of the progress with the EVM. So now the EVM gives more insight, not only two lines, whatever that we do about the tons of the steel we earn, or we whatever the is not only about those kind of things that we spend it, about money we spend it, right? We actually would like to know that, okay, what will be the actual progress and convert it to the end value. Okay, convert it to the end value so that we can use the end value to compare with the actual cost and also the plant expenditure, which is the PV, which is the schedule things, okay, that the plan things that we have. So now, yeah, please also very pay attention that now we were gonna start to talk about the EVM, and which is, I think the concept is very straightforward, very easy, but I still found that many students cannot really follow those kind of idea. Okay, in my previous years, this is just my observation. So I would like to let you really understand it how it works. So for the plan value, it's the data sources that integrated in the project's baseline and how much do you expect it to have down at the point X, like expresses it in dollar. Just like imagine this kind of data is based on your WBS, based on your network. All right, we accumulated all the result, the planning things that for the S curve, and that is that project management baseline. Okay, this is the PM baseline. That and then so that you can refer it to like each point. Then this is the for example, after the 1 month, 6 months, is you know that okay, this is $1 million. You need to spend 2 million or other kind of thing. You are gonna have this kind of plan for the plan value. And how much do you expect it to have down at completion? Then this is the BAC, the budget at completion, which this BAC at the end point, it should be the total budget. Is the it should be the higher it should be the total accumulated budget of your project. All right, this is a BAC. And for the actual costs, the data source is from also the end value management system, and the dollar amount actually spent today has no relationship to work accomplished. Okay, it's just like the money you spend. It doesn't really means that okay you complete what what is the percentage complete of your project. All right, so that for this one you now have another line means for example like here we have the actual cost in this point is 1 million something and compare with the PV. So you can see the differences. Okay, the PV and the AC, but they don't have any relationship. Okay, don't be confused. Now for the EVM, we don't treat it the we will never do calculation between these two values. Okay, we will never do that. We will compare what we will going to compare will be the end value with the actual cost and also the plan value. All right. So then this is the dollar value of the actual accomplishment today. The dollar value is like the actual accomplishment today and does not address the money spent in getting there. Okay, getting there. So that we will have another line, which is the EV here. All right. So then we were gonna start to talk about how we can really compare with them. So then there are also several ways to earn it. We can compare with the percent completion estimation, start finish of the WBS elements. I think we also discussed a bit before, but don't be confused that we need to treat it and convert this into the earn value, okay? And then so that we can really know, and then it's different with the money that we spend. It is different, okay? It's different. So that we can integrate it, have the performance report. Yes, I think Michael, this is also kind of concept that you can say that you can see that the PV we complete how much what the percentage of the PV, then this is the value that we really earn. So that for this one, now they have other kind of term can express. For example, the BCWS, the budget cost for work schedule, actually is the same thing for plan value. So don't confuse; they are totally the same. Okay, BCWS is just like the PV, and BCWP is the end value, the budget cost for work performed. And the ACWP is the actual cost of the work performed, which is the AC. So the BAC is budget completion, EAC is estimated in completion. And we will talk about
more that about variances and about how we can predict for the project completion. So for the embedding management, now we can do some like track, like control based if you now know understand these three different lines. So then compared with the traditional control method, now we were gonna use this EV to find out what is cost variance, what is the schedule variance. We were gonna use the EV minus the PV to get the schedule variances. The idea behind is that now we know that this is the actual work performed. So when we use this one, the EV minus the PV, then we can really know that okay, whether our projects, okay, whether our project is ahead of schedule or behind the schedule, right? Because we will compare with the real thing. And also, we use the EV minus the AC, which means that we can know the cost variances. Okay, whether that we spend too much or whether we already save some money. So that we were gonna do these two calculation to understand it, the schedule variances and the cost variances. So some common measures here is that the CV cost variances is equal to the EV minus AC is also equal to BCWP and minus ACWP. And schedule variances, then this AC is equal to the EV minus PV, and cost performance index, then CPI equal to the EV divided by AC, and schedule performance index, then SPI equal to the EV divided by PV, and then we finally can have the critical ratio, like the CR is equal to SPI times the CPI. So then here is just like some detailed explanation that for schedule variances, this is a kind of like we want to know like the percentage of this work schedule to have down and how much did I budget for it to cost. Like this is for the plan value, right? And BCWP then is the PV. So it's like the work I actually performed and how much did I budget it for it to cost. So for the schedule variances, it's the difference between the work schedule and the work performed and expressed in terms of the budget dollar. We can use the schedule variances equal to the EV minus the PV. Okay, so for this one, we have the 1000 minus 2000, and we can know that this is a negative 1000, which is negative and means behind schedule. And for the cost variances, it's like the differences between the budget cost and the actual cost. So we have PV is equal to BCWP minus ACWP. Then for this one, I think that the EV is still lower than the AC. So it's like 1000 minus the 2400, we get a negative, which is cost overrun for 1400. And the variance as a completion is a difference between what the total job is supposed to cost and what the total job is now expected to cost. So formula is like this. We have the variance as a completion, which is a BAC minus the EAC. So we will discuss how we can get the EAC later. But for this one, we will get for the BAC is 5,000 and minus 7,500. We get the negative 2,500, which is negative and means that all costs overrun. So that for monitoring those variances, if the SV is positive, we know it's ahead of schedule, and negative is behind schedule. And cost variances, if it's positive, then it's under running cost. And if it's negative, it's over running cost. And for the VAC, if it is positive, it's project underrun, and if it's negative, it's projects overrun. So that, and we can also know about the cost performance. And for this example, we use the EV divided by AC, then we get it actually is the 0.8175. And for this one, schedule performance, we can use the SPI, which is equal to the EV divided by PV. Okay, so we get the 0.851. Okay, 0.851. And then why we want to have those kind of ratio is also means something to help us to monitoring the performance. Like for some SPI and CPI, they are basic. If the CPI larger than 1, it's overestimated amount of the effort required. It may also means that for the measurement of the percentage complete optimistic or like better than the planned productivity.
However, if the CPI less than 1, it may be like underestimate the amount of work required and measurement of the percentage complete systematic and like poor, or it just means that poorer than the planned productivity. And if the SPI larger than 1, it may be means about the starting work out of sequences or just like better productivity than planned. If the SPI less than 1, there are different kind of meaning. For example, like possible understaffing because the schedule is ahead, schedule is delay has been delayed. If delay started, like work more difficult than planned, or like have improper sequences of the activity, or just have the poor work organization and execution. So it means that when we do those kind of project control, this value, when we get this value, also now you know that to get this kind of value is not difficult. However, when we get this kind of the value, it will actually give a sign to the project manager or the engineer is that okay, your project may have some problem, so that they may really look at about what what is the real problem that caused this project has this kind of warning. All right, so but I just list like some of the possibility so that they may can examine about those problems. And please also remember that the EVM allows the isolation of the schedule and the cost variances like this. For example, schedule variances, if it's negative number, we know that it's behind schedule. And the cost variances, if it's also negative number, then we just know that it's over cost. Okay, so don't be confused. When we do EVM, don't use any calculation between the AC and PV. It will always start it with considering the N value. Okay, it was always started with the N value. And then so for the monitoring performance, if we also look back about the project mass baseline, and you can see that here we have the plan value, we have the N value, and also the actual cost. So that we also know the EAC, we also have the management reserve. So we will see that, okay, whether that in the completion and variances, we were gonna also learn how we can predict it, the complete variances, okay, in the future based on the current status of the project and whether it will surpass the management reserve or not. All right. And then so we can also use this kind of a chart to determine, okay, whether using CPI and SPI to determine like in this quarter, in the right hand, the top right corner is like the quarter is the schedule advantage. If this is in the button of the right hand side, then it will be the schedule delay and cost saving. It's just something like that. This kind of chart can also give you some hint to control the projects. Then we can also utilize the critical ratio like this, like using the actual progress divided by schedule progress and times the budget cost and divided by actual cost to have the critical ratio for the factor S like this. If it is the within a range between the 0.9 to 1.2, then we can just ignore. And if it's the close to the point A, we should watch carefully and have the project engineer investigate it. If it's between the 0.6 and 0.8, we should investigate it immediately. Okay, something like that. This is another kind of chart that we can do for control. Okay, so then after that, so we talk about those kind of concepts. I would like to also use an example to let you understand it. How can we really do calculation for the EVM? So for this one, we will mainly discuss it about the EV and the AC and PV. How can we get it, the percentage complete, and also how can we get the schedule variances and the cost variances. All right. So then first, suppose that the work on the project task was expected to cost 1,500 and to complete the task, and the worker were originally scheduled to have the finish today. As of today, however, the workers have actually expended 1,350, and our best estimated that they are about 2/3 finish. So that this is kind of a supervisor opinion, right? Someone can already determine, okay, this is the kind of roughly idea that this percentage complete is like the 2/3. So that based on that, we can know that the EV, then it will be the uh, 1500. This should be the whole project finish. Then actually this is a BAC. Okay, this is a BAC. So that we use this 1500 times this two-thirds. So we get a PV and also minus the AC, the 1350. So we get a negative 350. So this is the cost variances. So what's good? So this is how we do. And for the schedule variances, we get the same EV and we minus the 150. Oh, sorry, it's 1500. So that will get negative 500. So this is the SV. And then for the CPI, then we just use the EV divided by AC, which will get the number as the 0.74. And the SPI then is 0.67. So what's good? So we just like extracted those kind of number and do the EVM calculation. So I think this will be the final part for today that we were going to talk about forecasting. We will leave the unscheduled, I would say later, probably next week. And so forecasting is that the baseline is composite of the many lower level elements, like the sum of the total value of the contract. So sum of all the BCWS, the PV will be the BAC. Okay, will be the BAC. So when all the work has been phases, the accumulated the PV should be equal to the BAC. So we want to do forecasting. Okay, it's just like this kind of another managerial implication that for the after we know those kind of variances, cost variances and schedule variances found in the EVM. So we assume that if we maintain the same cost performance index, then it will be like this. The estimated to completion, the ETC, should be equal to the bracket of the BAC minus the current EV, the BCWP, and divided by the CPI. Remember, this is because we have the assumption for maintaining the same cost performance index. So that is why we divide the CPI here. Okay, we divide the CPI here. Okay, so that we can also say that, okay, we can do maintenance the same cost variances, then the EAC can be just equal to the BCWP at condition and plus this ACWP minus the BCWP at the present. Okay, so that and for the maintenance and cost performance index, then we get the ETC like this, right? And then estimating the completion, then the total cost, then we will be the EAC is equal to ETC. We just got ETC and plus the AC. Okay, plus the AC. All right, so you just like have a different kind of method to really do for the estimated and completion. So you can see from this figure, we just like move these kind of cost variances, so we top up with the BAC, and then for this kind of top up, then it will also based on different kind of assumption, whether it will follow CPI or it just directly added this gap into the final BAC. All right. So then for the estimate to complete, like ETC, like how much will we have to spend is like after today to complete? This is just a question that we want to answer. So the total budget less what we have earned today, like with some assumption that we can have the performance today has been analogous or cost performance today will continue, or both the cost and performance today will continue. So we'll have a different kind of assumption. So don't ask me again because that I answer so many questions about from the students like this. Which one is correct? Should we use ETC as the BAC minus EV, or should we use ETC equal to the bracket of the BAC minus EV divided by CPI, or ETC is equal to the bracket of BAC minus EV divided by CPI times SPI? They are all correct. Okay, they are all correct. It's just different kind of assumption. I think I also repeat several times for many different for many calculation in this subject. We mainly based on a different kind of assumption. Okay, this is also like in reality. There's no perfect cost estimation. There's no perfect. Different kind of company, they may have a different kind of result. Okay, they just like really based on their experience and see. Okay, for example, when they want to do this estimate to completion. Some expert or the project manager may say that, okay, I guess it will follow the CPI, that cost performance, or it will gonna follow the cost and schedule performance. Okay, so unless I really indicated in the question, whatever in the like in the final exam or in the tutorial, we say that okay, we will follow some a specific assumption. If I didn't do that, then you just assume by yourself. You can do okay, performance today has been anomalous, so you will say that the ETC is just equal to the BAC minus EV. All right, so we can do that. You can really do that. And so yeah, don't ask me again. You can really do this unless I really indicated which one you should use, right? I think to answer Wong Park's question, I don't think this kind of the equation you need to provide, right? Because it's just like someone minus someone things. So it was I think it won't provide it. Those equation won't provide. All right. So then for estimated completion, then it's like how much will we have spent that when we are actually down? Like again, based on the same assumption as the ETC, the EAC is equal to AC plus the bracket of BAC minus EV. Okay, if it is like has been anomalous, right? And or you follow the CPI or follow the CPI times the SPI, all right? So you are gonna get the different kind of answer, but they are all correct. It just really depends on the assumption. All right. So then we continue with the EVM example one that we just down. So now we can use these calculations to determine some additional item of interest as well, like the ETC and EAC, if nothing has been done to correct the problem. So given that the budget at the completion, like BAC is 1500 and the EV is 1000. So if we just follow like this, we will gonna use the same CPI, then it should be the ETC is equal to bracket of the BAC minus EV and divide by the CPI, which is like this. 1500 minus 1000 divided by 0.74, which will get the 676. So know that there is assume that the work will complete at the same level of efficiency or inefficiency as conducted thus far. So the total cost to complete the task will be like this. We will gonna have this 676 and plus the current AC, the 1350. So the EAC will be equal to the 2026. Okay, 2026. All right. So then for TCPI, which is to complete the performance index, is like how well do we have to perform to get back on track? Like again, based on the same assumption as the ETC, we can have the TCPIC. Like 1 divided by CPI or 1 divided by SPI or 1 divided by the CPI times the SPI, we could just get a different kind of answer. All right. All right, I think we have 10 more minutes that I will gonna show you like this. Okay, I will gonna show you for this. Let me see. Okay. Okay, so now I think this is also a very important part that I always want to do is kind of like this, like each lecture we're gonna link with the previous one, and then this will be the one that can explain it how we can link with the project control with what you learned in previous weeks. Okay, since that for this table, I think everybody got very familiar with, right? We have the activity, we have task, we have the predecessor, we also have estimated time. So based on this, we have the relationship, we have the duration, so we can easily draw the network. And now we also have the estimated cost, like the BAC. This is kind of remember that we can treat it like we assigned the resources into those activity, right? Like money. So, but it just like now we call the PV here, the BAC here. All right. so that if we draw the AOA, oh sorry, this is not an AOA actually. It is the, let me see. Yeah, this is the AOA. So that we have start point linked with A, B, and then we have those arrow, and then treat it and to show the bar charts in the button of the figure, so that you can now see all these schedules of those tasks. And then if we also add that into the information like this, if now we have the field report, okay, remember that the previous table is more like the planning thing. We have the PV, we have all the network, we have duration. But how about you think about that we collect the field report. We have the data captures in the 8th week for this project. And then now you can see that, okay, we have the actual cost for each activity. Okay, for example, like activity A, we spend it 1,000, activity B, we have 1,200, we have C for 2,000, D for 1,000, E for 1,500. All right. And then we also have the information is the percentage complete at the 8th week for those activity. We know that the 100% complete for activity A, we complete 100% for activity B, we have complete 100% for C, 15 for D, 25 for E. All right. So that you also have the number of week out of total like this. So we have all these kind of information. So if we convert it and add it into the original plan, then we can compare, right? For the blue one, we have the actual one and compare with the yellow one, with the planned one. So we now know the A has 100% complete, B is 100, C also, but will only complete 50%, 25%, and also the G for 0%. Because we now know is the 8th week, we set up the line is somehow like here, right? If we go back to this line, number 52. So it means that the G, actually we should do it for 1 week. Okay, complete something, but we actually did nothing for that. We did nothing for that. So this will show that here, 0%. And this is the PV, like the 2,000 is the schedule item that we need to finish. All right, so that we can also do that. We can see the total cost for the each week and also cumulative cost for that. And then we can finally do like that. So we have the BAC for all this one, and then we, based on the percentage complete of the BAC, we get the EV. Okay, we'll get an EV, but the BCWS actually is for we know is for the 8th week, because for for example, like activity B is partially, it need to be partially finished in the week A. Okay, it's like this is the original work that plan to finish for the activity D in week A. Okay, and also 1,000 should be finished in the week A for activity E. And however, this is a percentage real conflict for 15%. Okay, for 15%. So we use this 15% times 2,000, we get the EV is 300. So now this 300 can compare with the PV as a 333.3. Okay, so that we also get the 0 for EV, but actually this 2,000 is a 1/4 of the activity should be finished in the week A. So then we can have the total for the total PV, the plan value should be 6,833. And then, however, for the EV, because we know the percentage complete of those PV, so we get the total as the 50/50 for the total EV in the week A. And we also know that this is the AC. So we know then now we can also calculate for the CV, CPI, SV, SPI for each activity, and also the sum of them. For example, like here, we have the 50/50 minus the this 6,700, we get a negative 1,650 as the cost variances. We use the EV minus the AC. So this is negative.
we also use this 50/50 divided by the 6700, we get the 0.754, and we use the 50/50, the EV minus the PV, 6833, so we get a negative 7083. Okay, and then we also got the 0.739 for our SPI. So we can now know that in the week A, this is over budget. This project now is over budget and behind schedule, which is the worst situation. So far so good. So far so good for this one. I think you probably need to spend some time to really digest, to link with those kind of all the information to get this table and do the further calculation. All right, so that is why I think I would like to stop here. Okay, stop here for today's lecture. 53. I think you can see from the question is that because we have the estimated that they are about 2/3 finish. So then 2/3 finish means that we just use this times the BAC, like the final PV, so that we can know the current EV is equal to 1000. Okay, then Michael, what did you say? CP1. What is CP1 and SP1? If they're equal to 1, then this is a perfect situation. Means that the EV is equal to the PV and EV is equal to the AC. So actually 1 is the target that we want to achieve. Okay, it means that the project progress perfectly follow the plan. Okay, so that's good for today. Yes. So which item we need to comment? What do you mean? So you mean that if the SPI and CPI is equal to 1, then how we can comment? Is that what you mean? I mean, over budget and behind schedule is based on the eighth week, based on the result that we just got, right? Is because it is the negative one, negative number, or the SPI and the CPI is less than 1. So it's over budget and behind schedule. Yeah, the example I just showed is because that, yeah, I already told you that that is the calculation result, right? Because it did not, you can refer it to the monitoring performance that, let me see, like in the, you can refer it to the page 44 and also page 47 and page 48, because that when we get the SV and SV and CV result, if this positive means something, negative also means something, and the SPI and CPI also means something, right? So that you can refer it to the criteria that I just mentioned in the previous lecture. So you can understand it why when we interpreted those results, I would say, okay, this is the over budget and behind schedule. All right, because that, for example, if AC is larger than EV, it means that you spend 2 more. The actual money that you spend is already is larger than the work progress, so it should be over budget. Behind schedule means that the EV is less than the PV. Okay, because that project did not really meet the expectation for PV. All right, so that's good.
So I think I will leave the time to demonstrate it, the previous group project to next week, since that now is almost 4:20, and then I will also like to let the Vahi to demonstrate it, the solution, and discuss with you the solution of the midterm. So if you have any question about the midterm, then you can also ask him. All right, so I will demonstrate it, the group project, the previous group project as an example, as a references later next week. All right, all right, and then so that you, after you discuss with Fahi about the midterm task, then you can start it with your tutorial today. And some of the students already requested about the extension of the tutorial. I think, yeah, I may move the deadline, postpone the deadline to tomorrow. Is that okay? Tomorrow 5 p.m. so that you can really, yeah, discuss it, the midterm things with Fahi. All right, so that you can yeah. Okay, then I will end of the lecture now, and then probably you can start it with the tutorial, like discussion with the solution of the midterm, like 4:25. Is that okay? 4:25. So I will see you guys next week.